All right, so problem 94, we have this television camera on the ground level that's filming the liftoff of a rocket at a point 800 meters from the launch pad. So that's what this diagram here is. Here's the rocket. Camera's over here. The horizontal distance, 800 meters. The base of this right triangle. And so we're gonna have theta be the angle of elevation. So this guy right here. So it basically describes how the rocket is elevating relative to how the camera, will have to shift its, angle to view it. So we're first going to write theta as a function of s for the period of time when the rocket is moving vertically. Then we're going to differentiate this result to find d theta dt in terms of s and ds dt. Okay, so this is kind of going back to kind of like how you learned related rates in chapter 2, and then also how we can use the inverse trig functions to give equations for an angle. So let's start off by using the cosine of theta. Remember, cosine of an angle is the ratio of the hypotenuse, or the adjacent over the hypotenuse, adjacent over hypotenuse. So the adjacent is 800. The hypotenuse is going to be s. So we need to find the equation for theta. So what we're going to do is we're going to take the inverse cosine of both sides of the equation, because that'll undo the cosine function. And then we'll get that theta is simply the inverse cosine of 800 over s. So that's our equation for theta. Now we're going to differentiate this with respect to t. So it's going to be like basically a chain rule, because s is also a function of t. So d theta dt will be d theta with respect to s ds times ds dt. Now, a refresher for what's the derivative of the inverse cosine is of a function. So using u substitution, the derivative with respect to x. What's going on with this pencil? D theta. So the inverse cosine of u will be equal to negative u prime over the square root of 1 minus u squared. You really only, so on your AP exam, like the only inverse trig function that really appears is tangent. Sometimes I've seen sine, but I've never seen inverse cosine or any of the other ones. But I'm not saying that it's not possible, but it's just very, very rare to see them. Anyway, so then in this case, our u is going to be 800 over s. Or we can say 800 s to negative 1. So then u prime will be negative 800 s to negative 2. And then so d theta dt, let me just go on to the next line over here. So d theta dt will be equal to the derivative of the inverse cosine with respect to s first. So the derivative of, so we're going to have u prime on top. So we're going to have negative 800 s to negative 2 all over the square root of 1 minus u squared to the square root of 1 minus, we made u 800 s to negative 1, so minus 800 over s, because that's s to negative 1, this whole thing squared. And technically, this whole thing is being multiplied by ds dt. which we're not going to be given. We're just going to leave our final answer multiplied by that. But let's clean this up a little bit. So then this is the same as negative 800 over s squared all over 1 minus, I believe 800 squared will be like 640,000. Yeah, 640,000. And we're gonna, since this is gonna be s squared, I'm gonna make the 1 s squared over s squared. So minus 640,000 over s squared times ds dt. We keep on working along. That's the negative 800. That'll be, let me think. Oh, and this, I bet this would be negative 800 s squared, because the derivative itself is negative, but u prime actually is negative. So this will be negative negative, and so that eventually just becomes positive. So we don't really have to worry about that. So it'll be positive 800 over s squared. Let's put the s squared in the denominator. So we're going to have d theta dt be equal to 800 over s squared times the square root of, so we'll have s squared minus 640,000 over this s squared here. And again, this whole thing times ds dt. So really, we're just working on some algebra trickery to make this look a little cleaner. So this will be then equal to the square. We can take out this s squared in the denominator because we're going to have the square root of 1 over s squared, which is just going to be 1 over s. So what we actually have then is to be equal to 800 over s squared, and then this comes out. This s squared of s squared comes out, and it's just s back on the outside, times the square root of s squared minus 640,000. All that times ds dt. And that just becomes s. So really, we just have 800 over s times the square root of s squared minus 640,000 times ds dt. So really can't clean this up anymore. Let's just write it all nice and clean. So 800 over s times the square root of s squared minus 640,000 times ds dt. Instead of leave your answer in terms of ds dt because we can't find the actual value of it. We don't have enough info. And so that'll be our solution. So there you go. I hope that helps. Good luck.